Hvala vam. Thank you. So this is quite a large topic, and I'll move through it quite quickly. If I am talking too fast, please come and talk to me afterwards, and I'm happy to try and explain a little bit more. If I can work out how to use this. Oh. So I'm going to talk about this quite large subject, but I want to focus on the practical steps that will move from the ambitions that we see with reducing carbon footprints, and I think we all understand the need to do that. But going from those fine words and bringing them down to actually making a change, sort of changes that Wolfgang's been talking about. And that's what I'd like to explain here. To do that is very simple. You need a comprehensive carbon management process. It has to cover all the aspects of this. Starting off with measuring, and that's actually the easy bit, which I'll come back to, but there's an example here. We saw some examples before. This is from a high-speed rail project in the UK. And just as Wolfgang was saying, you can see that the dominant influence of materials, in particular cement, as the component of concrete, and steel in there as well. Another thing to note here is it's the whole life. So we, of course, focus quite a lot on the what we call capital carbon, the things we're building, but we mustn't forget the operational aspect. Even if it's smaller, we, particularly in the design aspects, have a huge influence. If you to think about the alignment, the way you arrange an alignment has a big impact on the operations. So first of all, we've got to measure, and we have to measure from the very beginning. I think that's a point that's been made before. Then you can set the targets, and I'll touch on that. And in terms of acting, you have to act early. And finally, I'm going to come to the issue of procurement. So how do we arrange the contracts? How do we buy this infrastructure, which is very important. Measuring. That's easy in the sense that you're just looking at quantities. You've got emissions factors. Wolfgang gave a nice simple example about that. We love that as engineers. Numbers, lots of numbers, lots of detail. You can start to debate. Oh, is it 290, 250? That's meat and drink for us, and it's quite simple to do. There are a number of existing tools. That's all quite easy. And also, the framework is quite familiar to us. If you think about what I've mentioned previously, you could apply just the same to financial cost. You measure. We're all concerned about the cost about things. If somebody, for example, asks you, can you put the railway station in Ljubljana underground? I bet you the second question that person will ask is, how much will it cost? And we'll be able to come up with a number. We can also come up with numbers related to carbon cost at very early stage, and we have to, because that's where the big decisions are made. Once you know how big your problem is, you can then start to deal with the problem and look at how to reduce that. And that's quite straightforward. In a sense, we are given, or we will be given, targets. So the EU has its goals on its path towards net zero. And the sort of targets I'm talking about is, if you think about Scandinavia, where they're quite advanced in this, on current infrastructure projects, we have to reduce the carbon footprint by 40% typically for the projects that have been built now versus a 1990 sort of benchmark. If you think about 40%, can you make your concrete lining 40% thinner? Actually, we've spent quite a lot of time worrying about the thickness. There's some areas that we can look at, but that's relatively hard to do. Can we make the tunnel 40% shorter? That, again, what happens to the other 40%? Well, the other 40% that you've left behind. That's the sort of level of change that we're looking at, and we need to put this in as a binding target. So not an ambition. There's an expression in English: the road to hell is lined with good intentions. So lots of people have good ideas, but unless you make it a binding target which has a bonus or a penalty associated with it, if you make it a requirement, then you will have progress. Otherwise, and this is why partly we don't see progress in this situation at the moment. Act early. Again, we know this. This is very standard sort of way of thinking in terms of designing or any project. So if you want to change the alignment of a tunnel, when is it easy to do? It's easy when it's a line on a page, which sort of shows my my age. When it's a polyline in a BIM model, it's dead easy to change. When you're on site and the contractor says, I would like to move it 50 meters that way, that's a very difficult thing to do. So the progress we can make can be made most easily early on. And quite often, if you do it early, you actually have a cost saving associated. So you have you can have a very positive situation there. There is a tendency to sort of look at the end product and, what type of cement are we using in this and that? But unless you have set up the right framework at the beginning, for example, unless you have opened up the specifications to allow different supplementary cementitious materials, it's very, very difficult for a contractor to change anything at the end. And again, that's a reason that I see problems at the moment, or failure to deliver on this. Innovation has been mentioned before. We have to embrace innovation. I love innovation, but I agree with you, there are risks associated. However, somebody pointed out to me that the biggest risk we probably face in our industry is not innovating. If we continue doing what we've done for the last, 100 years, I mean, a lot of what we do is actually quite traditional, quite old style. Then we're going to find a situation as the pressure develops in our society, that people will probably turn around and say, I don't want a tunnel, because there's a huge amount of carbon involved in that, irrespective of the social impact associated with not building that tunnel. So the biggest the biggest risk we're facing at the moment is not innovating. We will not make progress using the same thing we did last year in the same way, because you just get the same outcome. You can manage the risk associated with innovation. That is actually quite straightforward to do. More straightforward than using this button. So that brings me to the last point, which is procurement. But before I go into that, there is, as I said, specifications. One way to open up specifications is to look at performance specifications. You do need to be careful how you write that. So those two things are similar, and one of them appears to be very green, but personally, I would never touch that green pint in a million years. For me, the performance specification of a pint of Guinness is, it tastes like Guinness. It has the same feeling, the same body. It has the nutritional value. Guinness is really good for you. And I don't mind about the color, but I won't be drinking the green thing. So there's a huge amount of marketing and blah blah about how green is this and so on. You have to cut through that, and there are ways to do that. Environmental product declarations, for example, give you a solid basis for evaluating two different materials. But fundamentally, the biggest issue we probably face at the moment is that the procurement system, as I think has been said earlier, is driven by cost, financial cost, and it's driven typically, even in quite developed systems of, with pre-qualification, quite often is a race to the cheapest price. That will not solve our problem. So carbon has to be evaluated in the process of awarding contracts, and it has to be a decisive factor. You have to shift the balance, and this is one of the reasons that we're not making progress at the moment. You also have to set up a contractual framework that permits changes, that looks for the good ideas. We've talked about all the ideas that you can drag from the different parts of this, from contractors and suppliers, as well as let's say from the operation team. Quite often in systems we forget about the people who actually have to use this. So to wrap up, I mentioned earlier that a typical requirement on let's say a road project in Norway is that you have to reduce the carbon footprint by 40% versus a 1990 baseline. Can we do it today? I love innovation. There's some really exciting things out there, but I really feel we need to be acting now, and we need to be using what we have in our hands. And there is a lot more detail in the paper, and there's a longer paper that is referenced in that, taking this example. And the short answer is yes, we can. And it was very nice to see Wolfgang showing similar sort of figures there. What you notice there is that the savings come from a change in the design concept. So it goes right back to the beginning. You have to be pushing designers. So I am a designer. I've spent a lot of time as a designer. We need to work harder. We need to be curious. We need to be looking for innovation. We need to be bringing that to clients. We need to guide clients, because quite often my experience is that client organizations have lost a lot of technical knowledge. So designers have a really important role, and too often it's sort of the copy and paste mentality. Because we're talking about a change in procurement system, that will be driven by the clients. So my appeal to any clients in the room is to show that leadership. Without that leadership by clients, unfortunately, again, nothing will change. But although it can be quite depressing thinking about sort of climate change and the impacts, this is an area where I feel quite optimistic. There are lots of things out there. We don't really use our current guidance, EN 206 for the concrete nerds in the audience, the concrete spec in Europe. We don't use half of the things that are in there. Quite often they're not permitted. The reason that things like this don't happen on those Norwegian projects is very rigid specifications from the client. A very technically knowledgeable client, but a very conservative one. We need to break that open. And if we do that, we can take what seem to be quite difficult and complex problems, which are also quite fun to deal with, and we can make the improvements. We can actually make things much better. Falaban.
Thank you, Alan, for your very interesting and pointed lecture. Do we have questions from the audience? If not, I will, while we are thinking, some maybe other questions. You put designer in the very narrow area of the key player in carbon reduction. Can you give us a little bit more thoughts on how designer can actually help? Because most of carbon reduction is actually in the hands of contractor and is not perhaps part of the design.
Yeah, so this is a good example here. Yes, the implementation is by the contractor, but what he's been asked to implement comes from the design. So hopefully nobody from Hamburg will mind me putting up this picture. This is the, I think it's the Furka tunnel in Switzerland. What's interesting about it is permanent spray concrete, which from the Scandinavian point of view is like, duh, that's obvious, but it's one of the rare tunnels in Switzerland which is permanent spray concrete in a tough geological environment. They had squeezing in these situations. They had to come back and put in extra spray concrete, but that's permanent spray concrete in, I don't know, 1980, something like that. You can't see the bolts, but they're permanent rock bolts, number one. And number two, they're glass fiber reinforced polymer rock bolts. That has come from the designer. I don't know how much dialogue there was with the contractor, and maybe if they were sensible, they were talking to contractors and saying, well, what do you think you could use here? But they've made use of very low carbon, it's a very low carbon solution basically. GFRP is a lower carbon than steel. And then permanent spray concrete without a sort of cast secondary lining gives you the best option. So that's where I agree with you. You need to have dialogue with suppliers and contractors. That's what makes good design inherently. But the decisions need to be made early. Otherwise, you bake in the carbon, and it is very, very difficult for a contractor at the end to change if he's given a rigid design.
I wonder here how they actually regulated the drainage, because that's why we use perhaps the secondary lining, which is from the cast concrete.
Yeah, short answer is that I don't know exactly, but I imagine it's where you had open joints, strip drains. It's fundamentally a drained tunnel.
Semi-drain pipes.
Yeah. So you're looking at pressure relief to that is the concept.
Okay, another question from the floor. We got just about time for another one.
Alun, have you come across a contract that supports innovation at job sites?
Yes. So one of the best examples is I worked on a project at Heathrow at the new terminal, where the contractor was brought in at a very early stage with the designer to develop solutions. And so it was a very forward-thinking client. Plenty of pressure. You had all the usual pressures of time and money and risk, you know, sitting in an active, well, you know very well yourself, Wolfgang, an active airport. I also see more recently in the UK, there have, as Arnold mentioned, there have been different types of contracts where you have, let's say, a more refined version of the design and build, where there's an opportunity for an overlap, where you have a dialogue with the contractor and the designer. The basic design and build is something I truly hate, because the design gets pushed down to the bottom. It's, you know, a subcontractor, and all subcontractors, unfortunately, in this world get kicked around. And you have no time, you don't have information. So that sort of optimized contractor involvement, early contractor involvement is what they call. Those things are much more aligned about creating the best solution. And that's, you have the right people in the right space, incentivized to get the best solution rather than the cheapest price. So yes, they exist.
Okay, thank you, Alan.